students, this is the second part of the chapter pair of linear equations in two variables. In this session, we will be covering exercise 3.1 questions, first, second and third. First one, form the pair of linear equations in the following problems and find their solutions graphically. First, 10 students of class 10 took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. See, the first condition is given as 10 students of class 10. So here girls and boys both are mentioned. So let the total number of boys equal to total number of boys equal to x and total number of girls equal to y. It is given 10 students. So girls plus boys equal to 10. X plus y equal to 10. Okay, this is the first equation. And see, the second condition is given as if the number of girls is y is 4 more than the number of boys. Okay, see, girls are 4 more than the boys. Okay, this is the second equation. Okay, now we will assume the values of x and we will find out the values of y. Okay, in the first equation, now take the first equation. Take this first equation. If x equal to 4, then 4 plus y equal to 10. Then y equal to 10 minus 4 equal to 6. Okay. If x equal to 5. If x equal to 5, 5 plus y equal to 10. Then y equal to 10 minus 5 equal to 5. Okay. If x equal to 6. So 6 plus y equal to 10. So y equal to 10 minus 6 equal to 4. Okay. Now take the second equation. Assume the values of x and we will find out the values of y. Okay. If x equal to 1, then y equal to 4 plus 1. So y equal to 5. Okay. If x equal to 0, then y equal to 4 plus 0. So y equal to 4. Okay. If x equal to minus 1, y equal to 4 plus of minus 1. So y equal to 4 minus 1 equal to 3. Okay. Now we will represent these two values on the graph. Okay. The first equation, see, this is the second equation. Okay. Second equation values. See, for the first one, if x is 4, y is 6. See, if x is 4, then y is 6 here. Okay. And if x is 5, y is 5. X is 5 and y is 5. Okay. See, if x is 6, y is 4. X is 6 and y is 4. Okay. Now join these points. Okay. When you join these points, you will get a line like this. Okay. Now let us represent this second equation values. Okay. If x is 1, y is 5. X is 1 and y is 5 here. If x is 0, y is 4. 0 and 4. Okay. 0 and 4 here. If x is minus 1, y is 3. If x is minus 1, y is 3 here. Okay. Now join these points. See, these two lines meet at this point. Okay, these two lines are intersecting and there is a unique solution, and this point is what? It is 3, 7. Okay, here the lines intersect at 3, 7. So here 3 represents x-axis and 7 represents y-axis. Here what we have taken for x-axis, we have taken, see, for x we have taken boys, and for y we have taken girls. So total number of boys, equal to 3 and total number of girls equal to 7. Okay. Now we will go to the next problem. See, second one, 5 pencils and 7 pens together cost 50 rupees, whereas 7 pencils and 5 pens together cost 46 rupees. Find the cost of 1 pencil and that of 1 pen. It is asking to find the cost of 1 pencil and that of 1 pen. So here let us assume cost of 1 pencil equal to x and cost of 1 pen equal to y. Okay, what is the first condition given? 5 pencils and 7 pens. 5, number of pencils are 5 into cost of each pencil, x, plus number of pencils are 7 and cost of each number of pens are 7 and cost of each pen is y. So 5x plus 7y equal to 50. Okay, this is the first equation, and here second condition is 7 pencils. Number of pencils are 7 into cost of each pencil is x, plus 5 pens. 5 pens together cost 46 rupees and number of pens are 5 and cost of each pen is y. Okay, equal to 46. Now this is the second equation. See, 7 pencils, 7x and 5 pens. Okay, 5 pens cost is 5y. Okay, see, cost of 1 pencil is x and cost of 5 pencils is 5x. Cost of 7 pencils is 7x. Okay, cost of 1 pen is y. Cost of 7 pens is 7y. Cost of 5 pens is 5y. Okay, equal to 50 and equal to 46. Okay, now we will assume the values of x and we will find out the values of y. Here, if x equal to 3, then you substitute x value in this first equation. Okay, 5 into 3 plus 7y equal to 50. So 15 plus 7y equal to 50. 7y equal to 50 minus 15. 7y equal to 50 minus 15 is 35. So y equal to 5. Okay. Now if x equal to 4. If x equal to 4, so 5 into 4 plus 7y equal to 50. So 20 plus 7y equal to 50. So 7y equal to 50 minus 20 is 30. So y equal to 30 by 7. It is 4.28. It is approximately 4.28. Okay. Now if we take x as 2. Okay. 5 2s are 10 plus 7y equal to 50. So 7y equal to 50 minus 10 is 40. So y equal to 40 by 7. 7 5s are 35. 50 7 7s are 49. 5.71. Okay. Second equation, if in second equation, if x equal to 3, if x equal to 3, then 7 into 3 is 21 plus 5y equal to 46. So 5y equal to 46 minus 21 equal to 25. So y equal to 5. Okay. If x equal to 2. Okay. 7 2s are 14 plus 5y equal to 46. So 5y equal to 46 minus 14 equal to 32. Y equal to 32 by 5. Okay. 5 6 are 30, 5 4s are 20 equal to y equal to 6.4. If you take x as 4, 7 4s are 28 plus 5y equal to 46. So 5y equal to 46 minus 28 equal to, see, 16 minus 8 is 8. Okay. 3 minus 2 is 1. Okay. So y equal to 18 by 5. Okay. 18 by 5 is 5 3s are 15, 6 5s are 30. Okay. 3.6. Now we will represent these values on a graph. Okay. Here from the first equation, if x is 3, then y is 5. If x is 3, then y is 5. Okay, this one. If x is 4, then y is 4.28. X is 4 and y is 4.28 here. Okay. If x is 2, y is 5.71. X is 2, y is 5.71. Okay. Now join these points. Okay. This is the line. See, for the second equation, if x equal to 3, then y is 5. See, if x is 3, y is 5. Okay, this is the point. And if x is 2, y is 6.4. X is 2, y is 6.4 here. Okay. If x is 4, y is 3.6. X is 4, y is 3.6 here. Now we will join these points. Okay. Now it will be something like this. Okay. Now here the two lines are intersecting and so it has a unique solution. What is that? These two are intersecting at the point 3, 5. Okay. Intersecting at 3, 5. See here, at the 3 represents x-axis and y represents 5 represents y-axis. Now here what is x? X is pencil, cost of pencil. X is cost of pencil and y is cost of pen. Okay. So here, therefore, cost of each pencil equal to 3 and cost of each pen equal to 5. Okay. Now we will move to the next one. See, on comparing the ratios A1 by A2, B1 by B2 and C1 by C2, find out whether the lines representing the following pairs of linear equations intersect at a point or parallel or consistent. See, we have to compare the A1 by A2, these ratios. Okay. See, from the first equation, 5x minus 4y plus 8 equal to 0. From here, A1 is what? A1 is coefficient of 5 and B1 is coefficient of y. It is minus 4. C1 is constant 8. Here in the second equation, 7x plus 6y minus 9 equal to 0. From this equation, what is a2? a2 is the coefficient of x. a2 equal to 7. What is b2? b2 is the coefficient of 6. And c2. c2 is the constant term. It is minus 9. Okay. Now we will take these ratios. a1 by a2 and a1. What is a1 by a2? Equal to 5 by 7. And b1 by b2 equal to minus 4 by 6. What is it? It is minus 2 by 3. Okay. And c1 by c2 equal to 8 by minus 9. So what can we say? 5 by 7 minus 2 by 3 and 8 by 9. Minus 8 by 9. Are these equal? No. These are not equal. So these are intersecting. See, if we saw that if a1 by a2 is not equal to b1 by b2, not equal to c1 by c2, then this condition tells that the lines are intersecting. Lines are intersecting at one point. Okay. Here the lines are intersecting. Okay. Now we will see the next one. See, these two are the equations given. We should compare a1 by a2, b1 by b2 and c1 by c2. From this equation, a1 is the coefficient of x. It is 9. So b1 is the coefficient of y. It is 3. c1 is the constant term. It is 12. From this equation, a2 is coefficient of x and b2 is coefficient of y and c2 is the constant term. Here a1 by a2 is 9 by 18, that is 1 by 2. Okay. And b1 by b2 is equal to 3 by 6. It is 1 by 2. Okay. And c1 by c2 equal to 12 by 24 equal to 1 by 2. See, from these three, we can say that a1 by a2 equal to b1 by b2 equal to c1 by c2. Okay. That is half. a1 by a2 equal to b1 by b2 equal to c1 by c2. See, if these three are same, if these three ratios are same, are equal, then we say that the lines are coinciding. Lines are coinciding. Okay. This has infinite solutions. Okay. Next one. See, from this equation, from the first equation, 6x minus 3y plus 10, a1 equal to 6, that is coefficient of x, and b1 equal to minus 3, that is coefficient of y, and constant term c1 equal to 10. From the second equation, a2 equal to 2, b2 equal to minus 1, c2 equal to 9. Okay. Now we will find out the ratios. a1 by a2 equal to 6 by 2 equal to 3 by 1 and b1 by b2 equal to minus 3 by minus 1 equal to 3 by 1. Okay. And c1 by c2 equal to 10 by 9. See, from these three ratios, we can say a1 by a2. See, this 3 by 1 equal to 3 by 1. a1 by a2 equal to b1 by b2, b1 by b2. But is b1 by b2 equal to c1 by c2? It is not. See, 3 by 1 is not equal to 10 by 9. So, if this is the condition, if this is the case, then the lines are parallel. Lines are parallel. a1 by a2 equal to b1 by b2 and not equal to c1 by c2. The lines are parallel. Okay. This have no solution. No solution. Okay. These are inconsistent. inconsistent. Okay, next one. See, on comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the following pair of linear equations are consistent or inconsistent. Okay, from the first equation, 3x plus 2y equal to 5, from here a1 is the coefficient of x, b1 is the coefficient of y and c1 is the constant, that is minus 5. See, if you take this 5 to the left side, what will it be? 3x plus 2y minus 5 equal to 0. Okay, from the second equation, this is the first equation. From the second equation, 2x minus 3y equal to 7. Now take 7 to the left side, 2x minus 3y minus 7 equal to 0. We can say that a2 is the coefficient of x, b2 is the coefficient of y and c2 is the constant term, that is minus 7. So here we will find out the ratios a1 by a2 equal to 3 by 2. Okay, and b1 by b2 equal to 2 by minus 3 and c1 by c2 equal to minus 5 by minus 7. Minus and minus gets cancelled. So here can we tell that a1 by a2, is it equal to b1 by b2? No, equal to b1 by b2 equal to c1 by c2. And is this equal to b1 by b2? No. So here a1 by a2 not equal to b1 by b2, not equal to c1 by c2. This is the case. If this is the case, then the lines intersect and this have unique solution and these are consistent. These have unique solution and these are consistent. Okay, this is what asked. These are consistent. Next one. See, in this equation, in the first equation, 2x minus 3y equal to 8. Take 8 to the left side. 2x minus 3y minus 8 equal to 0. In this equation, a1 is the coefficient of x, b1 is the coefficient of y, c1 is the constant term. Okay. Now take the second equation, 4x minus 6y equal to 9. Take 9 to the left side, 4x minus 6y minus 9 equal to 0. Now here a2 is the coefficient of x, b2 is the coefficient of y, c2 is the coefficient, c2 is the constant term. c2 is the constant term. Now we will find out the ratios a1 by a2 equal to 2 by 4. This is 4. And b1 by b2 equal to minus 3 by minus 6. And c1 by c2 equal to minus 8 by minus 9. Okay. So here 2 by 4 is 1 by 2. Minus and minus gets cancelled here. 3 by 6 is 1 by 2. Minus and minus gets cancelled. Here 1 by 2 equal to 1 by 2. Okay. Here we will write a1 by a2 equal to b1 by b2. And is this value c1 by c2 is 1 by 2? No. So this is not equal to c1 by c2. If this is the case, if a1 by a2 equal to b1 by b2 and that is not equal to c1 by c2, if this is the case, then the lines are parallel. Lines are parallel. They have no solution. These are inconsistent. These are inconsistent. Okay. Next one. See, from this equation, from the first equation, a1 is coefficient of x, 3 by 2. And b1 is the coefficient of y, that is 5 by 3. And c1 is the constant term, that is minus 7. See here, if in the first equation 3 by 2x plus 5 by 3y, and if you take 7 to the left side, if you take constant to the left side, minus 7 equal to 0. See here, constant term is minus 7. In the second equation, 9x minus 10y, and if you take the constant term to the left side, it will be minus 14. This is C2. Okay. In this second equation, A2 is 9, B2 is coefficient of y, that is minus 10, and C2 is the constant term, it is minus 14. Here we will find out the ratios. A1 by A2 equal to 3 by 2 by 9. What is it? 3 by 2, here 9 by 1 into 1 by 9. It is 1 by 6, right? And here B1 by B2 equal to 5 by 3 by minus 10. Okay, here by 1. Okay, 5 by 3 into 1 by 10 minus, okay, 5 2s are 10 equal to minus 1 by 6. Okay, now here C1 by C2 equal to minus 7 by minus 14. Minus and minus gets cancelled, it is 1 by 2. Okay, now can we say that 1 by 6 equal to minus 1 by 6? No. Here A1 by A2 not equal to B1 by B2. Okay. Now is this minus 1 by 6 equal to C1 by C2? No. This is not equal to C1 by C2. If this is the case, if all the three ratios are not same, then the lines are intersecting. The lines are intersecting. That means they have unique solution. If there is a unique solution, these are consistent. Okay. The pair of linear equations are consistent. Okay. Next one. See, from the first equation, 5x minus 3y, take the constant term to the left side, minus 11 equal to 0. From this equation, a1 is the coefficient of x and b1 is the coefficient of y and c1 is the constant term. Okay, and in this second equation, take the constant term to the left side, minus 10x plus 6y plus 22 equal to 0. Okay, here a2 is the coefficient of x, b2 is the coefficient of y and c2 is the constant term. C2 is 22. Okay, now we will take the ratios a1 by a2 equal to 5 by minus 10. Okay, it is minus 1 by 2 and b1 by b2 equal to minus 3 by 6. It is minus 1 by 2. Okay, and c1 by c2 equal to minus 11 by 22. It is minus 1 by 2. See here, minus 1 by 2 is equal to minus 1 by 2 is equal to minus 1 by 2. We can say that a1 by a2 equal to b1 by b2 equal to c1 by c2. If this is the case, we can say that the lines are coinciding. The lines are coinciding and these lines are consistent and these have infinite solutions. Infinite solutions. Okay, next one. See, from this first equation, 4 by 3x plus 2y, take the constant term to the left side, minus 8 equal to 0. From this, a1 is the coefficient of x, it is 4 by 3 and b1 is the coefficient of y, c1 is the constant term. And from the second equation, this, take the constant term to the left side, 2x plus 3y minus 12 equal to 0. Here in this equation, a2 is the coefficient of x, b2 is the coefficient of y and c2 is the constant term. Here now we will take the ratio a1 by a2 equal to 4 by 3 by 2 by 1. Okay, equal to 4 by 3 into 1 by 2. It is 2 by 3. Now take the ratio B1 by B2 equal to 2 by 3. Okay. And C1 by C2 equal to minus 8 by minus 12. Okay. Minus and minus gets cancelled. Here 4 2s are 8, 4 3s are 12 equal to 2 by 3. Okay. Here we can say that 2 by 3 is equal to 2 by 3 is equal to 2 by 3. Okay. Here A1 by A2 is equal to B1 by B2 is equal to C1 by C2. See, if all the ratios are same, in this case the lines are coinciding. These have infinite solutions. And these are consistent pair of linear equations. Okay. With this we end this session. The next 4th, 5th, 6th, 7th questions we will do in the next video. Thank you.